Today we will continue with the before example, that is the signals and process group. So mainly we will be concentrating on process group and its example. So what do you mean by a process group? Associated with every process there is an process ID, that is the PID, and the GID, that is the group ID. The entries are stored in the process table. Example, PID is 23 and the GID of the process will be 41. So GID is inherited during the fork system call. That is when the parent creates the child process, the child will get the same GID which the parent is having. Example, A is the parent, its GID is 41 and its PID is 25. A creates a child process B and the B will inherit the group ID of the parent process, that is 41, but the PID will be different, that is the PID is 35. Once again I'll be explaining, that is A will create a child process, and if the parent has the GID, that is the group ID is 41, child will inherit during the fork system call and it will get the same group ID, that is 41, and the PID it will get different. So how should you create a different group? Like for example, B has the GID, that is 41. Now if B wants to change its group ID from 41 to something else, it will be using the set group system call. So set group is used to create a new group. The kernel uses the process group ID to identify the groups of the related processes that should receive a common signal for certain events. Like why the kernel creates the group ID? Like shell has a group ID of 35. So all the persons who are belonging to the shell ID should get an same signal. So it has an group ID. Kernel saves the group ID in the process table. Processes in the same process group have the identical group IDs. So set group system call, you will see with an example also. So set group system call. It initializes the process group number of an process and sets it equal to the value of its process ID. Now you may not understand the definition. First we will see the syntax, we will see an example, then we will verify with the actual definition. So syntax is equal to group is equal to set p group. So set p group is a system call which is used to create a new group. So where group is the new process group number. Group means after you execute the system call, you will get a new group, that is GRP will be having a new process group number. A child retains the process group number of its parent during the fork system call. So the child will retain the process group number of its parent during the fork system call. That also we will see now. For example, B is the parent and its old group ID is 41 and it will create a child process. So first we will see that P is a parent, its old group ID is 41. So B has executed a set group system call. So B will get a new ID, that is 35. See, B has executed the set group system call. So it is getting a new ID, that is 30. New group ID, that is 35. After that it will create a child process C. Then C will inherit the group ID of its parent. So after the child has been created, it will inherit the new group ID, that is it will inherit 35. So GID of C is 35. B becomes the group leader because B has executed the set group system call, so it will become a group leader. GID of B is equal to 35, which is same as the PID, that is 35. Once again I'll tell you that it has executed the set group system call. So it is getting a new group ID, that is 35. So where how will this 35 be assigned by the kernel? So the process ID of B is 35. So the PID of B is 35. So whenever the B executes the set group system call, it will get the PID of itself. That is the group ID is 35. So the process ID of P is also 35. So this is how it will be working. So GID of B is 35, which is same as the PID 35, means the PID of B is 35 and it will also get the group ID also as 35 when it executes the set group system call. Otherwise it will be getting different, which the parent B's parent will be having. So now once again we will read this system call. Set group is used to system call. This is used to initialize the process group number of an process. That is, it will get the new process ID and set its equal to its value of the process ID. Just now I told you that the B's process ID is 35. So even that is why it will set it equal to the value of its process ID. So the group ID also it will set it to 35. So we will see an example, sample use of set group, page number 211 from the BARC book. So hash includes signal.h because we require some of the signal. Fsintel भी include करना पड़ेगा इसमें. Okay, so register int I. So this is an register data type. So you can work with bits also. So that is why we are using the register int. So set p group system call. So set p group is executed by the parent. Set group is executed by the parent also. So if you go to a for loop, we are creating 10 childrens, because see, in the for loop we have the fork system call. So we are creating 10 childrens here. If fork is equal to 0 means what? This part is executed only by the child process. So if fork is equal to 0 means what? This whole part is only executed by the child process. So what happens? First, this for loop is executed 10 times. Its meaning is what? That 10 children are created, executed by the 10 children. Now, if you go inside, if fork is equal to 0, the first child is executing. So I and 1. I and 1 you will be getting 0. 0 and 1 you will be getting 0 only. So 0 and 1 you will be getting 0. So if 0 means it is false, so you will not execute the set group. You will print the PID and you will also print the group ID and you will pause. Next, once again I becomes 2. So I becomes 2, I becomes 1. So I becomes 1 means what? The second child is executing. 0 means the first child, 1 means the second child. So I is equal to 1 means the second child is executing. If fork is equal to, so second child is executing. If 1 and 1 you will be getting true. So only the first child, that is 0 will not execute the set group, that is the second child, that is C1. Like if you take 10 children like C1, C2, C3, C4 up till C10, if you will take 10 children, C1 will not execute this set group P group. Why? Because 0 and 1 it is false. Next time we are repeating the loop with I is equal to 1. So 1 and 1. 1 and 1 means it is true. So C2, like we will take the children from C0 to C9. C0 to C9. So C0 will not execute this set group system call. C1 means what? It is the next child. So C1 will execute this set group system call and it will get the new groups. After that, once again we will repeat this. It will printf its PID, and then it will be pausing. But after that, again the system call will be suspended. Like next time the I becomes 2. So for the third child will be executing, that is C2, because C0, C1, C2. Now the I value is what? 0, 1 and 2. 2 and 1 you will be getting 0. So 2 and 1 is 0, so it will not execute this set group system call. So you should understand that here only the odd children will execute the set group system call. So you should understand this set group system call, only the odd children will be executed, that is C1, C3, C5, C7 and C9. Only the odd group children will set the new groups, whereas the even groups, that is the even children, will not set the new group. After that they will print their IDs. Pause का meaning क्या है? All the 10 children are being paused until they receive the signal. So after this 10 times the loop will be executed, and after that you will come out. Then the kill system call. Kill system call is used to send the signals, but to whom it is sending? 0 and SIGINT. 0 का meaning है send the signal to itself and to the same people who belong to this, and to the same processes who belong to the same group ID. So kill will SIGINT means interrupt signal will be sent to the processes to itself, and also to the processes who belong to the same group ID. Means what? Now even children will send the default behavior, because this is executed by the parent process. So in this case, the even children we are not set to the new group. Only the odd children are set to the new group. The even children still belong to the parent group only. So they will get the signal. So they will get the interrupt signal. Means what? All the even children will get the signal, and the default behavior is exit. As we have not given any behavior handle the signal, so the default behavior is exit. So even children will get the signal and the default behavior is exit. Odd children will continue the loop. Once again I will repeat now. If I and 1, first time the for loop is 0. 0 and 1, first we will assume that there are 10 children, C0 till C9. Okay, and after that, if I and 1 means what? 0 and 1, it will be returning false. So the set group is not executed. Next time I is 1. So C1 is executing this. C0 has not set the new group. C1, I and 1 means what? Like I and 1 means 1 and 1. So it will set the new group. C1 will set the new group. C2 will also set the new group. C2 will not set the new group. C3, odd children, C1, C3, C5, C7, C9 will set the new group, whereas all the even children will belong to their parent process. So when this is executed, odd children will set the new group, and when you come outside, kill system call is parent will execute this. So kill system call is executed by the parent. So kill is taking what? 0 value. 0 value means send the signal to itself and to the processes belong to the same group. So this SIGINT, that is this signal is sent to the even processes. Even processes means what? Like parent will send the signal to C0, C2, C4, C6 and C8. So it will be sending the signal to the even group. So even child will get the signals and the default behavior is exit. All odd children will continue the loop. Thank you.